I said we have to, amen, yeah, we have to, yeah, yeah. So you are all welcome back. Sorry for the break in transmission. You are all welcome back. Yeah, so as I was saying, we have to use to multiply 6x, you get 8x, then times x plus 2, minus, use this 3 to multiply this bracket, 3x minus 6, close bracket times this, then plus use this 19 to multiply this bracket, this first bracket, you have 19x minus 38, right? 19 times 2, 38 times x plus 2, amen, equals to what? 0. Because when you use this to multiply this, it's going to give you 0. Do you understand? Are you following? Okay? So, if you can see what I am saying, it's simple as ABC. So what we need to do is for us to multiply out this 18x times x, we are going to have 18x squared. Then 18x times 2, you have plus 36x, right? Then if I were you, don't be in haste, leave it in the bracket. 3x times 2x, 6x squared. 3x times minus 1 minus 3x, then minus 6 times 2x minus 12x, then minus 6 times plus 1 plus 6, amen, then plus 19x times x, you have what? 19x squared, then 19x times plus 2, you have plus 38x, then minus 38 times x minus 38x, and minus 38 times 2 is minus 76, right? Minus 76 equals to 0. Am I right? Look at the board very well. I hope I'm right. Right? Okay? So far so good. We are breaking it down gradually. Yeah. We are breaking it down gradually. Okay? Yeah. Okay, so let us open these brackets. Here will now be 18x squared plus 36x. Open this bracket, minus, use this minus sign to open this bracket. You are going to have minus 6x squared, minus times minus plus 3x, minus times minus plus 12x, then minus times plus minus 6. Then open this bracket plus 19x squared plus 38x minus 38x minus 76 equals to what? 0. So at this point, you don't need a prophet to tell you that 8x minus 38 is 0. This and this will cancel. So what we need to do here is for us to collect like terms. This and this are like terms, two of us. So 18x squared minus 6x squared, then plus 19x squared, amen. Then plus 36x plus 3x plus 12x, then minus 6 minus 76 equals to 0. True or false? Any question at this point? Do you have any question? Yes or no? Any question? Yes or no? Any question? No question? It means we can proceed, right? Okay, let's proceed. So now, at this point, what we need to do here is okay, let us add this and subtract this. So, okay, 18x squared minus 6x squared. We are going to have 14x squared, then plus 19x squared. Here is x squared, right? Here is 13, right? Plus this 13 carry 1, 2, 3, 33x squared, right? Am I right? Okay, so here we are going to have 33x squared. Then let's add this 36x plus 12x plus 3x. We are going to have x. Here is 5. 5 plus 6, 11. Carry 1 to this 4, 51. True or false? So here is plus 51, right? Plus 51x. Then here, minus 6 minus 76 is minus 82, which is equal to 0. You can now see that we have reduced this to a quadratic equation. True or false? True or false? It's true. Oh, it's true. I don't know whether we are right or wrong. Let's look at it together first. Yeah, let's look at it together again. Okay. You use this to multiply, you get this. Use this, you get this. 36, right? Yeah. Use this, you get this. Use this, you get this. True or false? Then use this, you get this. Use this, you get this. Use this, you get this. Then use this, you get this. So at this point, this one, you open this one, you get this, you get this, right? Yeah. Yeah. This time, this, we get this, right? And we get this, right? Okay. Then we get this, then minus, we get this. So by the time we open this, get this, get this. Okay. Then we get this. This and this will go. So here, this and this will give us, oh, sorry. Sorry, not 14, yeah. Sorry, not 14. This is where we made a mistake, yeah. From here, 12x squared plus 19x squared, yeah. 11, 1, 2, 3, yeah. So here is 31, please. Take note, 31x squared. So this is a quadratic equation. So you either use formula method or any method that you want to use. Is that clear? So that is what we are going to do. That is what we will do tonight. Yeah. So if you can see what I am saying, so let us use either factorization method or completing the square method. So if you can see what I am saying, here will give us x minus 1, then times 31x plus 82 equals to 0. By the time you multiply out this, you still get back this. So this is x minus 1 equals to 0, or 31x plus 82 equals to 0. Amen? Yeah. So x1 equals to 0, or 31x is equals to minus 82. Then x1 is equals to 1, and x2 is equals to minus 82 all over 31. So this is how you are going to solve this type of problem questions whenever you come across something like this. Mind you, you are going to see this type of question in your exam. Take note. Is that clear? Very important. Yeah, it's very important. So far, so good. We'll move to look at calculus tonight. Because of light issue, we are able to solve only one problem in quadratic. So let's consider calculus. Is that clear? Let's consider work with time. So let us try to consider calculus, so that at least we can solve some problems. Yeah. Do you understand? Is that clear? Are you following? Okay. So far, so good. Yeah. Oh, look at calculus tonight. Calculus tonight. Look at calculus tonight. Calculus tonight. Look at here. Yeah. Oh, look at log functions. Logarithmic functions. Logarithmic differentiation. Is that clear? We look at logarithmic differentiation. Amen? Yeah. Logarithmic differentiation is simple as ABC. Okay. So let us consider logarithmic differentiation tonight. Amen? Okay. So let's proceed to consider logarithmic differentiation. As simple as ABC, or look at the laws of logarithmic differentiation. And it is 211 that is calculus. Is that clear? Calculus. Logarithmic differentiation. Yeah. Differentiation. Logarithmic differentiation. Yeah. So, you know, in our elementary algebra, elementary trick and algebra, in log, the laws of logarithms, that is one of the laws. It says that if we have Then 3. If we have log a raised to the power of 10, this is the same thing as log n log a. True or false? That is indices, our elementary mathematics, isn't it? Yeah, it is. But here, instead of, since we are talking about calculus, has to do with what? Functions. So instead of log, we are going to use 1 in A, B is the same thing as in A plus in B. Amen? Then 2 in A all over B is the same thing as in A minus in B. And 3 in A raised to the power of n is the same thing as n in A. Do you understand? Take notes. So this is what we'll be using up to. So you have to take note of these properties. We have 3. So instead of, in elementary trig and algebra, we are used to this. But now we want to apply it in calculus. So for that, we are going to use in, no more log again. Is that clear? So in AB, that is A times B, talking about product multiplication law, is the same as in A plus in B. Then in A all over B is the same as in A minus in B. Then in A raised to the power of n is the same as n in A. Is that clear? Do you understand? So we'll be working with this. We'll be working with this. So take notes. Are you following? Take notes. Yeah. So let's consider some examples. Let's consider some examples. But before we do that, let us, okay, amen. Let us fix idea with some example. Example, if y equals to in x, they will say find dy all over the x. It's simple as ABC. What you do, you write solution. Amen. Our y is equals to in x. Whenever you differentiate in x, is that clear? It will always give you 1 all over x. So here we now be dy all over the x is equals to 1 all over x. So take note, even if you are asked to differentiate in t, it means your dy all over the t is equals to 1 all over the t. What if you are asked to differentiate y equals to in theta? It implies that our dy all over the theta is equals to 1 all over theta. Please take note. Is that clear? Take note. Are you following? Are you following? Do you understand? Is that clear? Okay. So, yeah, it's simple as ABC. So let's move further to solve more examples so that you understand this concept of calculus. Amen? Amen. Okay. Yeah. What if you are asked to differentiate if y equals to in 2x? Yeah. It means and find dy all over dx. It means solution y is equals to in 2x. So your dy all over the x will always give you 2 all over x. Yeah. It's going to give you 2 all over what? X. Is that clear? Yeah. So let us proceed to consider some examples. Amen. Okay. Let's proceed to consider some examples so that let's proceed to consider some examples. Yeah, another example is if y is equals to in open bracket 3x squared, amen, 3x squared plus 2x minus 1 plus 2x minus 1, and you are asked to find dy all over dx. Is simple as ABC. It is not difficult. Y is equals to in open bracket 3x squared plus 2x minus 1. Amen. What you need to do here is differentiate what is here, then divide it by the function. That is the answer. So if you differentiate 3x squared plus 2x minus 1, you are supposed to have 6x plus 2. True or false? Then you need to divide this. Don't include the in. That is the answer. So this implies that our dy all over dx will now give you, when you differentiate this, you are going to have this. Then use this to divide it. So here we are going to have 6x plus 2 all over what is inside here, 3x squared plus 2x minus 1. So when you look at this and this, it's the same thing. We did the same thing here. Since we have in 2x, differentiate this. Any answer you get, use it to divide this. Yeah. Use to divide the x. Yeah. Because it's a constant. The 2 is a constant. So that is that. That is that. Is that clear? Okay. So let's proceed further. Let us proceed further to consider. Okay, what if we now have what if y is equals to in x raised to the powers of 5? Yeah, it's simple as ABC. It's not difficult, amen? It is very simple as ABC. So what you need to do here is, it's not difficult. You write solution y is equals to in x raised to the powers of 5. So what you need to do is try to differentiate what is here. What is here? X raised to the power 5. Then your result is to divide this. So if you differentiate x raised to the power 5, you are going to have 5x raised to the power 4. So divide it by this. So our dy all over the x is equals to 5 raised to the powers of what? 4 all over x raised to the power 5. Amen. Then this is the same thing as 5 all over x. Because, excuse me, because when you apply indices here, 5 all over x. True or false? True or false? True or false? True or false? It's true, right? Okay. So let us proceed further to solve more examples. Okay, let's proceed further to solve my example. So let us have this as simple as ABC. Amen. It is simple as ABC. Let us have this. So far, so good. So logarithmic differentiation. Let's have this example. If y equals to x plus 1 raised to the powers of 2 raised to close bracket raised to power 2, then square root of x minus 1 all over, amen, all over kx root all over x root x plus 2. Yeah, let's look at this problem. Then it said find dy all over dx. Amen. It's simple as ABC. It's not difficult. So what we need to do, let us write solution. Our y is equals to x plus 1 all in square, then x minus 1, amen, all over x root x plus 2. Yeah, if I were you, go back to the laws of logarithmics. That is 1 in AB is equals to in A plus in B, right? 2 in A all over B is equals to in A minus in B, amen. 3 in A raised to the powers of n is equals to n in A, amen. So what you are going to do when you come across functions like this, what you need to do is for you to take Napierian log on both sides. Is that clear? So it means you are going to take Napierian log on both sides in y equals to in this in will affect the whole of this. So here will now be x plus 1 all in square, then square root of x minus 1, then all over x times square root of x plus 2. Amen? Yeah. Then put the brackets. Do you understand? So this is how to approach this type of questions. So what you need to do here is you have to apply the laws of logarithms here. But before then, let us consider the left hand side. Now when you differentiate in y, since this has to do with what? Respect to x. If you differentiate in x, you are supposed to have 1 all over x, 2 of us. Then now we have in y. So what are you supposed to have? You are supposed to have 1 all over y, 2 of us. But since we are differentiating this function with respect to x, we are going to have 1 all over y dy all over dx is equals to, now we apply the laws of logarithmics differentiation. So here, look at this idiot here. If you can see what I am saying, let's do it this way. This is the same thing as which of the law is applicable. Look at here and look at this one. 1, 2, 3. Somebody should tell us which of the law. We are going to apply the second law. Excuse me, 2 of us. We will apply the second law here. So what we need to do here is, when we have this, it means we are going to have in open bracket x plus 1 all in square, then times x minus 1 close bracket, true or false, then minus in open bracket, the same thing applicable here, x roots x plus 2, true or false, then close the bracket, true or false, is true, okay. Then here look at this place very well, look at this place very well. We are going to use which of the laws here, this and this. Somebody should tell us, look at the board and tell us which law is applicable here. Which law is applicable here? Yeah. Which law is applicable here? Which law is applicable here? Somebody should tell us. Somebody should tell us which law is applicable there. Okay, yeah. But before we do that, let us transform this here. Let's transform this here. Because when we have x minus 1, square root of x minus 1, this is the same thing as what? X minus 1 raised to the power of 1 all over 2. True or false? Likewise, when we have root x plus 2, this is the same thing as x plus 2 raised to the power of 1 all over 2. Amen? So, as root 1 all over y dy all over the x now be equals to, in open bracket, x plus 1 all in square times x minus 1 all in 1 all over 2, then close the bracket, minus in open bracket x times x plus 2 all in bracket raised to the power of 1 all over 2, then close the bracket. I hope I'm right here. True or false? It's true, right? It is true, isn't it? True or false? It's true, right? It's true, right? Am I right? Yes, no. Yes or no? Is yes. So now, what we need to do here is we have to apply one of the laws here and one of the laws here. But mind you here, we have a negative sign here. Is that clear? So if I were you, you put this in bracket, right, minus, put it in bigger bracket so that it will not confuse you. But let the minus sign exist outside. Is that clear? Just concentrate here. So which of the laws are we going to apply here? We are going to apply here first law. So because two functions are multiplying each other, true or false? We have a function here, we also have a function here. So 1 all over y dy all over the x will now be equals to, in x plus 1 raised to the power of 2, then plus in x minus 1 raised to the power of 1 all over 2, then minus, don't be in haste, like I always say. Then which of the laws is applicable here? We have a function here, x, and we also have another function. So the first law is applicable here. Then here will now be in x plus in open bracket x plus 2 close bracket raised to the power of 1 all over 2, then close the bracket. Can you now see, right? So we can easily multiply out these brackets. Amen? Okay, so here we are going to have 1 all over y dy all over dx is equals to, yeah, we can apply one of the laws here. Which of the laws is applicable here? Somebody should write it in the comment section, please. Which of the laws is applicable there? Which of the laws? Somebody should help us. Which of the laws is applicable there? Engineering student. Yeah. Chidira Amudu. Thank you very much. Yeah. And James Sunday, thank you. Samson. Yeah. Log 3. Okay. Log 3. Excuse me. So we are supposed to use log 3 here. So these two will now come here. 2 in open bracket x plus 1. Then plus, we are still going to apply log 3 here. 1 all over 2 in open bracket x minus 1. Then let's multiply, use this minus sign to multiply this. 1 minus in x. Then minus times plus minus in open bracket x plus 2 all in raised close bracket raised to the power of 2. So let me take it up so that I can get it. Okay, so now at this point, what we need to do here is yeah, we have to transform this one this way because log 3 is applicable here, true or false. So here we have 1 all over y dy all over dx is equals to 2 in open bracket x plus 1 plus 1 all over 2 in open bracket x minus 1, then minus in x minus 1 all over 2 because log 3 is applicable open bracket, sorry, all over 2 in open bracket x plus 2. Am I right? Am I right? Are we good to go? Any question at this point? Any question? At this point. So we can continue, right? Okay. Yeah. So if you say we should continue, this implies that, you know, you all know that when you differentiate in x, what you're supposed to have? You are supposed to have 1 all over x. Then if you differentiate in x plus 1, you are supposed to have 1 all over, because if you differentiate what is inside here, you are going to have what? You are going to have 1. Then use it to divide what is here, x plus 1. But supposing you have in open bracket 2x plus 1, you are supposed to have, if you differentiate what is inside here, you have 2, true or false. So 2 all over divide by what is here. Yeah, take notes. So let's differentiate this equation. So 1 all over y dy all over dx is equals to 2 times, if you differentiate in x plus 1, you have 1 all over x plus 1, because already if you differentiate x plus 1 is 1. So if you want to divide, then plus 1 all over 2 times, if you differentiate in x minus 1, you have 1 all over x minus 1, because if you differentiate x minus 1, you are supposed to have 1, then use it to divide the function. Is that clear? Then minus, if you differentiate in x, is 1 all over x, then minus 1 all over differentiate in x plus 2. If you differentiate x plus 2, you are supposed to have 1, true or false. So it will now be 1 all over x plus 2. Any question at this point before we proceed, please drop your question. Drop your question. No question, we can proceed, right? Okay. So if you say we should proceed, it's simple as ABC. We proceed. Let's proceed. So 1 all over y dy all over dx is equals to, use this to multiply the 2. You have 2 all over 1, 2 all over x plus 1, sorry. Then plus, if you use 1 to multiply 1, then we have 1 all over 2 open bracket x minus 1, because 2 will multiply the denominator, true or false. Then minus 1 all over x minus the same thing applicable, 1 all over 2 open bracket x plus 2 close bracket, true or false. So now at this point we are asked to find the 1 over dx, not 1 all over x, the 1 over dx. So we'll cross multiply. When we cross multiply, we'll have our dy all over dx is equals to y. You put everything here in brackets. 2 all over x plus 1 plus 1 all over 2. If you multiply out 2x minus 2, then minus 1 all over x minus 1 all over multiply out 2x plus 2 times 2, 4. Right? Then you close the bracket. But note that what is your y? Note that y is given as x square root of x minus 1, isn't it? All over, is it x, sorry, x minus, coming? Yeah, x square, x plus, x plus 1, all in square, then square root of x minus 1, all over x, square root of what? Square root of x plus 2, right? X plus 2, true or false? Yeah, this was our x, if I'm not mistaken. This was our x, so y, sorry, this was our y. So, as you can see, we have to substitute in for y to obtain the final answer. Is that clear? So, at this point, what we need to do here is, therefore, our dy all over the x is equals to, what is y? Y is this, amen? Y is this. Our dy all over dx is equals to, y is this, x plus 1, all in square, then square root of x minus 1, all over x, square root of x plus 2, then open bracket, 2 all over x plus 1 plus 1 all over 2x minus 2 minus 1 all over x minus 1 all over 2x plus 4. This is our final answer. This is how you are going to differentiate this type of functions using logarithmic differentiation. Is that clear? So any question? Do you have any question? Any question? Yes or no? Please, I give you guys 1 minute to ask question before we proceed further to solve more examples. Yeah. Before we proceed further to solve more examples. No question? So you mean we can continue, right? We can continue, right? Okay, let's continue. Okay. Yeah. Let us look at this problem. It's simple as ABC. Let's consider this problem. It is not difficult, right? Yeah. Let's consider this problem. Okay? Let's consider this problem. If y equals to, so I can take everything. Okay? Please don't forget to share this video in any of the groups you belong to. Okay, another example. If y equals to root square root of x minus 2 all raised to the power of 3 all over, amen, all over x plus 2 raised to the power of 3, amen. Oh, 2, sorry, this is 2, then open bracket 2x minus 1, amen. Yeah, think I'm right. Then he said find, which is comma, find dy all over dx. It's simple as ABC. Is that clear? So what we need to do is write solution. Y is equals to, let's just transform it together so that it will be more faster. You know that if you have a raised to the power 3 all in square roots, this is the same thing as a raised to the power 3 open bracket raised to the powers of 1 all over 2, true or false. So at this point we apply power law. If we apply power law, we are going to have a raised to the powers of 3 all over 2, true or false. It's true, right? So it's because of this. So if now, since we have square root of x minus 2 raised to the power of, this is the same thing as x minus 2 raised to the power 3, then raised to the power of 1 all over 2, then this is the same as x minus 2 raised to the power of 3 all over 2. Amen? True or false? Yeah. So we can transform this in this form, x minus 2 all in bracket raised to the power of 3 all over 2, then all over x plus 2 all in bracket square times 2x minus 1. Amen? So at this point, what are we going to do? Since they said use logarithmic differentiation. So you take Napierian law on both sides. It means this is the meaning. In y equals to in, then open bracket x minus 2 raised to the power of 3 all over 2, then all over x plus 2 all in bracket square open bracket 2x minus 1. then you close the bracket. Now, the left hand side, if we differentiate in y, we are going to have 1 all over y dy all over the x, because we are differentiating with respect to what? X, right? So we are going to apply the laws of logarithmics here. So who can tell us which of the laws is applicable here? We are going to use first law, and we'll also use second and third law. Two of us, all of them applicable here. In the long run, two of us, all of them applicable here, isn't it? Yeah, it is. So let us move further to consider this. So what we need to do, this is the same thing as in open bracket x minus 2 raised to the power of 3 all over 2, then minus, as I told you, if I were you, put a bigger bracket, then in x plus 2 raised to the power 2 times 2x minus 1, then close the bracket. Is that clear? Don't ever be in haste because of this negative sign. Because if you are not careful, you are going to miss the right answer. It will be difficult for you to arrive the right answer. So here is 1 all over y dy all over dx is equal to, we apply third law here, 3 all over 2 in x minus 2, then minus open bracket here, we are going to use first law, because we have two functions multiplying each other here. Here will now be in x plus 2 all in square plus in 2x minus 1. Close bracket. Two of us is 2, right? So far so good. 1 all over y dy all over dx is equals to 3 all over 2 in open bracket x minus 2, then let's minus close bracket, apply the third law here, 2 in open bracket x plus 2, then plus in open bracket 2x minus 1, then close the brackets. Amen? Two of us. Then here is 1 all over y dy all over dx will now be equals to, let us differentiate this. We are going to have 3 all over 2 times 1 all over x minus 2. Because when you differentiate x minus 2, you are going to have 1, then use it to divide the function. Then minus open bracket 2 times, if you differentiate this, x plus 2 is the same thing, 1 all over x plus 2, then plus, if you differentiate 2x minus 1, you are going to have what? 2, isn't it? So you use it to divide, so here will now be 2 all over 2x minus 1. Then, at this point, can I clean this up? Yeah. We are going to, hope you are enjoying the class. Is very interesting, right? Yeah, so here, 1 all over y dy all over dx is equals to 3 times 1 is 3 all over 2 open bracket x minus 2. Then what we have here, let us multiply out. 2 times 1 is 2 all over x plus 2. Then minus times plus here is minus 2 all over 2x minus 1. Two of us. I hope I'm right. Am I right? So now we are asked to find the y all over dx, not 1 all over y. So what we need to do, we cross multiply. So our dy all over dx now be equals to y open bracket 3 all over 2 all over minus 2. Amen. close bracket, minus 2 all over x plus 2 minus 2 all over 2x minus 1. Then you close the bracket. But you know that your y is this. True or false? True or false? Any question at this point? True or false? It's true, right? Okay. Your y is this. So what we need to do here is we have to substitute a for y here. Since our y is this, let me write the final answer out here. So therefore, our dy all over the x is equals to, what is our y is this, we write it in this form. Whichever way, minus 2 all in bracket raised to power 3 all over 2. Is that clear? So all over x plus 2 all in square, then 2x minus 1, then times 3 all over 2 open bracket x minus 2 minus 2 all over x plus 2 minus 2 all over 2x minus 1. This is the final answer. Any question before we move further to consider more examples? Please, if you have any question, ask. Amen. Ask your question. Yeah, ask your question. No question? Yeah, Samson, sir, why is n not indicated from the beginning? How do we know that this is a logarithm? Yeah, it will specify that you use logarithmic differentiation. I've said it here now. I wrote that I wrote logarithmic differentiation. Is that clear, Samson? So it will be specified. They will specify it. Use logarithmic differentiation. Is that clear? But there are some they will not specify, which you supposed to know. Okay, so let's consider one more example. This one, another example, it says evaluate dy all over the x if x equals to minus 1, where y is equals to, amen, equals to x plus 2 all in bracket raised to the powers of x. Like questions like this, you don't need them to say use logarithmic differentiation, because already is log you are going to apply. Otherwise, you won't get the answer. Is that clear? So now let's write solution. It's simple as ABC. Y is equals to x plus 2 all in brackets x. So when you come across this, what are you supposed to do? You take Napierian log on both sides, isn't it? So it means in y is equals to in open bracket x plus 2 raised to the powers of what? X. So what you need to do here is you differentiate the left hand side, 1 all over y dy all over the x. Then which of the law is applicable here? Third law, isn't it? So the third law means if we have if we have in A raised to the powers of B, this is the same as B in A, isn't it? True or false? is true, right? So here will now be x in open bracket, x plus 2. It's simple as ABC. So here will now be 1 all over y dy all over dx. Amen. Then, what are we going to do here? What are we going to do here? Huh? What are we going to do here? We use product rule to differentiate this function, two of us. We use product rule. So let's apply product rule direct. So we differentiate this function direct, right? So if we hold this, differentiate this, or hold this one, differentiate this, we are supposed to have x. If we differentiate in x plus 1, we differentiate in x, we are supposed to have 1 all over x plus 2. Two of us. Sorry, or say x plus 2. Then plus, we hold this one, then differentiate x. If we differentiate x is 1, use it to multiply in. So in open bracket, x plus 2 times 1, isn't it? So 1 all over y dy all over dx is equal to this times this is x all over x plus 2 plus in open bracket x plus 1. Amen? Amen. Yeah, at this point we need to write dy all over because multiply because y open bracket x all over x plus 2 then plus in open bracket x plus 2. Am I right? True or false? True or false? It's true, right? Oh yeah, Joy, I don't understand this logarithmic question. You don't understand. We differentiate inside the bracket. Yes, now that is what we are doing now. If we apply product rule there, we differentiate inside the bracket. We are supposed to have 1 now. So use it to divide the function, which is x plus 2, isn't it? Yeah. Yeah, you can ask me question tomorrow in class. Is that clear? Okay. So far so good. So our at this point, what are we going to do? We need to write our y, our dy all over the x is equal to our y is this x plus 2 open bracket raised to the powers of x, then as x all over x plus 2 plus a open bracket x plus 2, then close the bracket, 2 of us. But note that x is given as minus 1, so our dy all over the x is equals to 1 plus 2 all in bracket raised to the powers of minus 1, isn't it? Oh, sorry, this is minus 1. Minus 1 plus 2, then close bracket minus 1 all over minus 1 plus 2, then plus a open bracket minus 1 plus 2. Amen? Close bracket. So here we are going to have 1. So it implies that our dy all over the x is equals to, here is 1 raised to the power of minus 1, isn't it? Then open bracket. Here is minus 1 all over 1, isn't it? Then plus a 1, isn't it? True or false? true or false? Is 2 right? Because in 1, just like log 1 is 0. So here is 0, right? Then here we now have dy all over dx is equals to, this is the same thing as 1 raised to the power 1 times minus 1, right? True or false? Is 2 right? Okay? Yeah. So far, so good. So if you can see what I am saying, this will give us plus. So here our dy all over the x is equals to plus 1 times minus 1. Then this is equals to minus 1. This is the final answer. So far, so good. Thank you for your patience and your time. May God bless you all. God should increase you in wisdom, guide you on how to study and understand very fast. I wish you good luck. Please don't forget to share this particular video. Thank you and God bless you. See you guys tomorrow. See you here Wednesday, same time, same venue. Bye. I love you guys.